Assalamualaikum. Selamat sejahtera. Kita continue untuk exercise 1, question number C. We want to calculate the pH of the solution at the equivalent point. As we know, at equivalent point, mole acid akan sama dengan mole base. Okay, also we can write like this: mole acid equals to mole base. That means you have to use this formula, which is MAVA over MBVB, A over B. The stoichio A and B here refer to the equation between reaction HCl and NaOH produce NaCl and water. The stoichio here is 1 and base also 1, so you can simplify MAVA equals to MBVB because this is 1, is also 1. We know when M multiplied by V will get the mole. So molarity acid here is 0.2, volume is 25. Molarity base, that means your titrant is 0.2, and volume base you want to find. The VB here is 25 ml. Why I use this formula? Because it involves neutralization, acid and base. So this is the volume of the titrant added to the conical flask here. Okay, 25 ml added to the conical flask here and reach the equivalent point. So this is the first step. Okay, you find the volume base or volume titrant at equivalent point. The second part, okay, the second step, you have to find the mole. Mole for what? Mole acid. Okay, mole acid MV over 1000 here, which is 0.2, 25 over 1000, you will get 5 exponent negative 3. And mole base, your titrant, MV over 1000, so molarity base. Volume base is volume titrant you added at equivalent point. Okay, over 1000. This is 5 exponent negative 3. This is the mole in conical flask. This is the mole that you added from burette to achieve equivalent point. Okay, itu soalan minta achieve equivalent point. Okay, step number 3, you must use ICF table. Okay, automatically you must use ICF table. So you starting with equation first, right? NaOH plus HCl, single arrow become NaCl here plus H2O. Okay, compulsory to include the phase or the substance, and H2O as usual a liquid. Initial, change and final. When you use ICF table, the unit is only mole. So initial mole, for base and acid refer to the step number 2, which is 5 exponent negative 3, 5 exponent negative 3. Not yet produced, H2O not involved in this ICF table. For row change, you have to choose the smallest number between these two reactants. Okay, because we choose a limiting reactant. But for this case, the value is similar. So, you just write that value. No problem. And then you added the sign, negative for reactant, positive for product. The final mole for base will become 0, 5 minus 5. HCl also 0, 5 minus 5. Your NaCl become 5 exponent negative 3. Then, you buat satu lagi row. Refer to the molarity yang besar, which is mole over volume total. Volume total here is referred to volume HCl plus volume titrant NaOH at equivalent point. So, is 0, 0, 5 exponent negative 3 over 25 plus 25 exponent negative 3. So, you get the value is 0.1. Okay. Next, step number 4. Here, look at this molarity row. Yang berbaki hanyalah salt sahaja. Okay, hanyalah salt. So di sini, kalau kamu nampak yang berbaki pada row molarity hanya adalah salt, dia hanya ada value, bermaksud itulah yang berbaki. Bermaksud kita tak boleh guna if table sebab dia bukan strong. Okay, since dia adalah sejenis salt, that means kita kena refer kepada subtopik salt hydrolysis. Remember how to do the salt hydrolysis? You dissociate first your salt. Your salt here is NaCl. Dissociate will become Na plus equals NCl minus equals. As we know, cation from base and anion from acid. Suitable base that produce Na plus is NaOH. Suitable acid that produce Cl minus is HCl. Then classify the strength. This is a strong base. Classify the strength of acid here is a strong acid. Since both ion is strong, that means we can conclude, okay, Cl minus and Na plus cannot ionize in water because it comes from the strong base and strong acid. So, the salt NaCl is neutral salt. Okay, with pH equals to 7. So this is a pH at the equivalent point, which is 7, because this salt is 100% dissociate in the water, so it will become the aqueous solution in your conical flask. So bermaksud inilah yang berbaki, NaCl inilah yang berbaki di dalam your conical flask. So garam itu bukan dalam bentuk solid tetapi dalam aqueous. Bila kita check dia punya pH dia menjadi 7. Okay. Dan ada satu, ini adalah method yang pertama. Okay, all this we call as method yang pertama untuk tentukan pH pada neutral salt. Okay. Method yang kedua saya nak tunjuk untuk membuktikan dia juga pada pH 7 is you guna formula water dissociation constant. As we know, X and X, right? So X will become 1 exponent negative 7. X equals to concentration H plus mean 1 exponent negative 7. Okay, yang ni kita buat X lah. Kita anggarkan adalah dia sama daripada water dissociation constant H plus and OH minus here. Okay, di sini adalah liquid, di sini adalah aqueous, di sini adalah aqueous. That's why dia ada X dan X. Okay, so di sini boleh cari pH negative log exponent negative 7 and you get 7. Okay, kenapa yang ini boleh diterima sebagai metode yang kedua? Because di dalam conical flask kamu hanya ada salt yang larut di dalam water. So dalam conical flask itu ada water. Okay, based on this equation. Nampak? Di sini masih ada water. That's why based on this water lah kita mencari pH di dalam conical flask tersebut menggunakan water dissociation constant. Sebab masih wujudnya H2O di dalam conical flask tersebut. Okay, so metode pertama daripada aspek salt hydrolysis, metode yang kedua daripada water dissociation constant. Both accepted because it proved that the solution in the conical flask at equivalent is 7 neutral. Okay, now we go to the next, which is 1D here. Calculate the pH of the solution after addition of 30 ml NaOH. Remember, when it said in the question total of 30 ml, that means this is a final volume of titrant. That means your volume titrant after addition here 30 ml. So no need to use MAVA or MVPB because it not involve the equivalent point. Okay, right. After you get the volume titrant, step number 1, you go through step number 2, which is find the mole HCl using MV over 1000, 0.225 over 1000, and you get 5 exponent negative 3. And volume your NH is 0.2. Volume here, volume NOH, that means volume titrant you added is 30 ml. Okay, and divide by 1000, get 6 exponent negative. This is a mole in conical flask. Okay, this is the mole that you added. Okay, from burette. Okay, for 30 ml. This is the mole. Okay, after you added 30 ml titrant. Okay, next step you have to do ICF table. As usual, you starting the equation. What the equation? Equation reaction titration. That means strong base and strong acid here. Okay, initial, change and final mole in the unit. Okay, so initial mole for NOH from part 2 6 exponent 3, 5 exponent negative 3, 0, H2O not involved. Again, for change row, you select the smallest number, refer to the limiting reactant here. Since HCl is the smallest number, 5 exponent negative 3, we choose that number. Apply to all the species. Okay, jangan lupa letak sign untuk reactant, positif untuk product. So here we get 1 exponent negative 3. This is 0, 5 minus 5, and 0 plus 5, 5 exponent negative 3. Then you find the molarity. Okay, you added one row below to get the molarity. Volume total here refer to the volume HCl plus volume titrant at 30 ml. Okay, so 1 exponent negative 3 divide by volume HCl 25, volume you added adalah 30, 55, tukar jadi liter, and you get 0.01818. Okay, this has become 0 sebab no more mole here, and 5 exponent negative 3, volume acid 25, you added 30, and you convert into liter, and you get 0.0909. Okay, after you get the molarity, you kena tengok yang berbaki. Okay, ini ada 2 molarity, bermaksud ada 2 spesies yang remain di dalam your conical flask. Satu adalah molarity NaOH dan satu lagi adalah molarity NaCl. So this is the salt, this is your strong base. So berbaki ini siapa yang dominan? The answer is strong base. Okay, kalau remaining dalam conical flask adalah campuran antara strong base dan salt, dominan yang menguasai pH dalam conical flask adalah strong base. So kalau strong base, macam mana kita nak cari pH strong base? Yes, kita kena refer kepada if table. Okay, now you have to do if table. If table for what? Strong base, which is NaOH. Aqueous 100% dissociate, will become its ion. Okay, then your initial, your final, the unit is always molar. So since this molarity for NaOH 0.01818, initial no, at the final the molarity for NaOH will become 0 because 100% dissociate. This is a stoichio 1 to 1, that means the molarity is similar. Okay, then di sini kita nampak molarity OH minus is 0.0181. So from the OH you can find POH. Okay, 1.74. The question asks you about pH. So pH equals to 14 tolak POH. 14 tolak 1.74, and you get 12.26. This is the pH after you added 30 ml titrant into the conical flask. Okay, now you want to sketch titration curve. Before you start sketch titration curve, you have tabulate the data of the pH that you obtained from the previous question. Okay, for part A, okay, you have to plot pH here, right, and volume and AOH. Okay, mil. Okay, always this is a pH analyte. Always this is a volume titrant. Always. Okay, pH refer to pH analytes. This volume is volume titrant. Okay, now pH volume before added titrant. That means volume NOH is 0.00. You have to record 2 decimal places because the solution comes from the burette. Okay, burette reading must be 2 decimal places. So for part A, before added titrant, that means volume NOH 0.00. The pH is 0.7. After you added at half equivalent point, volume at half equivalent point is 12.50. The pH is 1.18. Alright, and after you at equivalent point, okay, the volume at equivalent point is 25.00. The pH is 7. Right, and the final addition of titrant is 30 ml. The pH will become 12.26. So this is data that you must tabulate in the table. Actually, this value is come from question A, question B, question C, and question D. You have to tabulate first. This is will get mark. Alright? Okay, after you tabulate, you starting to plot, sketch y-axis. This is pH. And your x-axis here, this is volume, and AOH in mil. Okay, before added 0. This is 12.50. This is a 25.00. This is a 30.00. Okay, then this is a 0.7. Okay, 0.7 here, and this is 1.18. Okay, this is a 7. And 13, 12.26. Okay. Your curve, you must remember, okay, that for type 1, the pH range must be 4 to 10. pH range here refer to pH for equivalent point or curve. Right? So since you kena carilah P 10, katakan 10 di sini. Kan katakan di sini adalah 4. So that means pH range 4 to 10, that means refer to the equivalent point, okay, refer to the steep part. Remember steep part? Which is steep part is the line almost vertical. Okay, so starting from 4 to 10 here. Okay, 4. I'll do the steep part first, and then baru saya turun, touch all the point here. Then di sini baru saya increase gradually. So this is steep part. Okay, refer to the pH range of equivalent point 4 to 10. You must include the pH range. Okay, all the point, other point compulsory lah. Okay, but steep part ini wajib ditunjuk untuk 4 hingga 10. Tengok balik type 1 atau type 2 ataupun type 3. Okay, alright, that's all.